All right, so part of the lesson today is using stuff that we learned previously to do something different, to actually find those ordered pairs. And so in topic 3.2, we learned that to find the cosine of theta, you're going to do x divided by r. But what we can do is solve that for x. What would you do to solve that for x? Multiply by the r. So if we want to find the x coordinate, it's going to be the radius times the cosine of whatever angle is there. And then for the sine, we learned that the sine of theta is y over r. So same thing, we can multiply by that r and get that y is going to be equal to the r times the sine of theta. All right, so that is going to give you the coordinates. So if you know the radius and you know the angle, you can find the ordered pair there. All right, so example 1 takes us back to some geometry stuff that you guys learned. So on example 1, this figure shows a circle with radius 4 along with an equilateral triangle. The triangle is PQO. Which of the following is the coordinates of Q? All right, so what do you guys know about the angles of every triangle in the world? The add to equal 180 degrees, but we don't think in terms of degrees anymore. So what would that be in radians? Pi. They would add to equal pi. So if I added these angles in radians, they would add to equal pi. So for an equilateral triangle, what do you know about these angles? They're all the same. So what should one angle be? If they're all the same and they add to equal pi, it's going to be 1/3 pi, or pi over 3. All right, if I made another equilateral triangle by doing that, this angle is also pi over 3. And what this question is asking us to do is to figure out the coordinates for Q, or what we would do to find them. So Q is here. So according to this, we could do the radius times the cosine of the angle. Now what my last class people got so thrown off because they were thinking in terms of triangles, and you don't need to do that. You need to think in terms of angles this year, which is a rotation from the positive x-axis to that line where Q is. What would that angle be? 2/3 pi. All right, so then which choice do you guys think it is? C, good job. All right, now that is why it is what it is. I'm fine with you all not doing all that work. Some people need to know why, and I understand that. Some people are just like, tell me what to do. So remember, I don't know what day it was. It might have been on Thursday, or it could have been before. If the angle is closer to the y-axis, which kind of special angle is it going to be? Yeah, it's going to be a pi over 3 angle. And so then in quadrant 2, the pi over 3 angle is going to be 2 pi over 3. All right, if it had happened to be drawn closer to the x-axis, what kind of angle would it be? Pi over 6. And so if it was this one right here, which one would that be? Somebody whispered it. 7 pi over 6. What if it was straight in between? It's a quarter. It's a pi over 4 angle, and then you just figure out which quadrant. So I wouldn't do all this stuff with the equilateral triangles. I would just think that way, because they're going to be special angles. Okay, so let's look at the next one on example 2. So this figure shows a circle of radius r, and then we have a line that is y equals negative x. So the circle and the line y equals negative x intersects at doesn't really intersect at O. The circle and that line intersect at R and P. And so we know the coordinates of P, which is great. And so what we need to find is what the radius is, what the value of R is. Bless you. Now we don't need it for this problem, but what would you say that angle would be from here to here? In radians, it's a pi over 4 angle. Which one? 7 pi over 4. Good. We don't need that right now, but I'm just trying to get you ready for the next thing. Okay, so we know x and y, and we want to find r. Do you guys remember how to do that? I don't think I heard that. So it's basically, it's basically the Pythagorean theorem, but we don't use a, b, and c. We use x, y, and r. All right, so in for x, I'm going to put in 6 square root of 2. In for y, I'm going to put in negative 6 square root of 2. And then r is what we're looking for. All right, so when you square that, you do actually square the 6, which is 36. But what do you get when you square the square root of 2? That's just 2. Good. All right, and the same thing here. We're square negative 6, which is still 36. And you square the square root. All right, and then this is something that you would be expected to do without a calculator. So do you guys, can you double 36 in your head? Yeah. And then when you add those, you get 144. So what's r? Just 12. Good. All right, any questions about that? Okay, so let's keep working with the unit circle. So what we did on Thursday was just figure out the angles. But the whole unit circle has angles and ordered pairs. All right, and so this one, we just have the ordered pair, but what angle is like straight to the right, no rotation at all? 0. What about straight up? Straight up? Oh, half pi, pi over 2, good. And to the left? And down? Good. Those were the 4 angles I thought you would learn first. Okay, and then on the unit circle in the last class, we also talked about how you find the sine and cosine and tangent. We're not doing tangent today though. But if we wanted to find the sine of an angle on the unit circle, what would we do? Like, what would we use to find it? Y over r, and what would r be on the unit circle? 1. And so if we want to find the sine, it's just y. And if we want to find the cosine of an angle on the unit circle, it's just x. Now you could still do over r if you wanted to. It would just be a slight waste of time because it's just 1. You don't need the r. Okay. So if I have these 4 angles on the unit circle, and I want to find the cosine of the angle 0, I go to 0, and which coordinate do I use for the cosine? 1. I use the x. Then if I want to find the sine of 0, I go to the angle 0, and then I'm just going to use the y coordinate. All right. And then for cosine of pi over 2, I go to the angle pi over 2, and then I just give the x. And then sine pi over 2, I go to pi over 2, and then I just give the y. All right, you guys finish those other 4 for me, please, if you haven't already. Do you understand that? This is the x versus y. On the order there, that's the x and that's the y. If you want to find the sine of an angle, all you get is the y here, or simple y. If you want to find the x, the cosine, you just give the x. All right, check your stuff with mine. Okay, so those are the quadrant angles. The sine and cosine of the quadrant angles are either going to be 0, 1, or -1. There'll be nothing else for sine and cosine. All right, then we have all those angles that are inside the quadrants. So you have 3 special angles in each quadrant. And so I'm going to go through and just like write out all this stuff that Brian Passwater has typed up. You don't have to write it if you don't want to. If you need to write it to understand it, then feel free. But let's talk about another unit circle where we have another equilateral triangle where all the sides are going to be 1 because it's equilateral. This angle is closer to the x-axis, so what is that angle? Pi over 6, yes. So this angle of theta is pi over 6. Oh, it says it right there. So it is. All right, and then since this is 1, then this height is 1/2, and then this height is another 1/2. So what would the y-coordinate be at point P? 1/2. It's how many you go up to get it. So what we need is the x-coordinate there. And so to find the x-coordinate, I'm going to use the Pythagorean theorem, but using x, y, and r. So x is what we need. Y we already know is 1/2. What's r? 1. All right. Do you guys know how to square a fraction? Yes, 1/4. You just square the numerator and you square the denominator. All right, and so then if I'm solving this for x, I'm going to take 1 and I'm going to subtract 1/4 from it. What am I going to get? 3/4. And then finally, I'm going to take the square root. Do you guys know how to find the square root of a fraction? You just take the square root of the numerator, which is the square root of 3, which won't simplify. And then the square root of the denominator is just 2. So there are 2 possible x's. Which one is it going to be, the positive or the negative version for point P? It's going to be the positive. Good job, guys. All right, so on our unit circle, when the angle is pi over 6, then the ordered pair there is going to be square root of 3 over 2 and 1/2. All right. And so the pi over 6 angles in the other quadrants are going to have some version of this fraction or of this ordered pair. It's just sometimes the x is negative, sometimes they're both negative, and then sometimes the y is negative. All right. All right, so let's go to that. There we go. There they are. All right, so a review of Thursday's lesson is to figure out if this is pi over 6, what angle this is, and this is, and this is. All right, so at Q, is pi over 6 less than pi? So what is that? 5 pi over 6, good. All right, R, is pi over 6 more than pi? Good job. 7 pi over 6. And then S is pi over 6 less than 2 pi. Nice job. Okay. Okay, so that's a review. If you weren't here on Thursday, you probably want to go back and watch that lesson because it was crazy important for everything we're going to do for a long time. All right, so now what we're going to do is all of these ordered pairs are going to be some version of this. It's just something will be negative or maybe they'll both be negative. So in quadrant 2, which is where Q is the x or y going to be negative?
X.
The x, good. So it's going to be negative square root of 3 over 2 and then 1/2. All right, what's negative in quadrant 3? Both. And then 4, it's just the y, good job. So we're going to do that same thing with the pi over 4 angles in the next table. Bless you. All right, so we have some work that shows how they figured out that when this is a pi over 4 angle, your coordinates are square root of 2 over 2 and square root of 2 over 2. So we're going to apply that to the other quadrants. So when we're doing the pi over 4 angles, do you guys remember the shortcut I told you as you go around? It's the next odd number, pi over 4. And so for Q, it's going to be 3. Yeah. R is 5. And S is 7. Okay. And then same thing, we're going to apply the negatives where it's appropriate. Okay. And then the last one is the pi over 3. And I see some of you have already started working on it, and that's amazing. Great job. If you weren't here, or if you just don't remember, the pi over 3 angles aren't too terrible to do in the other quadrants. And so you just kind of go around. So this one was 1 pi over 3. All right, and the next one would be 2 pi over 3. 3 pi over 3 is actually going to be pi, right? And then the next one would be 4 pi over 3. And then 5 pi over 3. And then 6 pi over 3 is going to be 2 pi all the way around. All right, so you guys go ahead and take the ordered pairs at pi over 3, please, and figure out the positives and negatives for the other quadrants. And then you can see below, try not to work too, can't tell where people are, is the whole unit circle. So the whole unit circle has all the angles, and this one labels the angles on the inside of the circle. It doesn't matter where you do it. And then all their ordered pairs. So soon, hopefully by tomorrow maybe, you're going to be able to recreate this on your own. And so I heard someone in my last class say, like, if you can just memorize this first quadrant, then just reflect it throughout the other parts, then it's not that hard to remember. All of the little fractions have 2 as the denominators, and then your numerators is going to either be a 1, a square root of 2, or a square root of 3. All right, so on the next page, you have an almost blank unit circle. And I want you to try and do this without flipping back and forth. And so figure out the angles that aren't labeled yet. and then all these ordered pairs. And you can just use the first quadrant to get all those ordered pairs. I guess it's kind of crowded. I'm going to zoom in to each quadrant so you can double check yours. there's quadrant 2. And there's 3. My commas look like this says 21, but it doesn't. There's no 21 on the unit circle. Right, and then there is quadrant 4. And again, there's no 21 on the unit circle. Alright, and then we're going to go through, and I'm going to do the first row and I'll let you guys finish it up. And so we're going to find the sine and cosine of some angles that are on the unit circle, the special angles. Alright, so we're going to start with sine of 2 pi over 3. So we go to the angle 2 pi over 3, and if I want to find the sine, which coordinate am I going to use? The y. So the sine of 2 pi over 3 is going to be the square root of 3 over 2. And then the cosine of 5 pi over 4 will go to the 5 pi over 4 angle, and for cosine we just use the x coordinate. Right. And then the cosine of 11 pi over 6, go to 11 pi over 6, cosine, use the x coordinate. Alright, so you guys finish the rest of those for me, please.